You know me a little bit.
Make a graph.
No chart, no table, no graph, no. I want to find y prime. So that's my question. I have to find y prime. And for that, I can't use the graph. I don't have f of x. So I just need to find y prime. But I have two options. Either use the quotient rule. However, I don't want to. I prefer changing the function into x to, very good, multiplied by f of x. I'm not trying to avoid to use the quotient rule. I just think that this is easier. Because the denominator is only one term. Otherwise, I can't do this. Yes, please, go ahead, Jalen.
So you're changing this, you can use the product rule instead of it?
Exactly.
Okay.
So then y prime, by the product rule, the first function prime, -2 times x to -3, multiplied by f of x, first function prime times the second function, plus the first function times the second function prime. I can stop here, or I can simplify it a little bit. If I simplify it a little bit, you'll say, oh, well, then why didn't you use the quotient rule? That's fine, too. Will give us the same answer, of course. So then y prime equals, what is the greatest common factor of this term and this term? There's a common factor in both. It's x. Now I have to decide which power, and it always must be the smallest of the two. -3. So this is -2 f of x plus
X.
exactly f prime of x. Awesome. Now you can change it back into a fraction. But this was easier in my opinion. And this is y prime. Say it again. Was that the question?
Yeah, it's x.
Combined x to.
So x to
-2 minus x to the negative.
Correct.
Or time.
Yes, multiplied.
Out.
Yes. So here it is.
It's like the -2 exponents minus negative.
Exactly. Yes, because they know very well because I tortured them last semester with this constantly. So x to -3 times -2 times f of x is that. X to -3 times x will be x to -2 times f prime. Caesar, is that okay? So when you distribute it back to check the answer, this times this is that. Is that clear? But then copy the base, multiply, and copy the base and add the exponents because we multiply. -3 plus 1 will give us the -2. Is this okay? So now you see the application of that handout, right? Nico and Joey, right? It was for this basically because we haven't really used it throughout pre-calc. It was all of a sudden thrown at you, but it was for this. Yes, please.
So if you use the
Quotient rule, we get the same thing.
So
you want to use the quotient rule?
So there must be an x on top that cancels out one of the x's on bottom.
Of course. Of course. Because the denominator would have been x to the 4th. Of course. Okay, so let's look at one with a graph and then we can continue.
I got a quick question.
Yes, but I'm sorry, yes. Sorry.
So at the very bottom of the page, is that still supposed to be y prime?
Yeah, it's plus. It's plus. She have the
You mean here?
Oh no.
Yes,
sorry,
it continues.
I didn't see the little.
That's the first.
I didn't see the semicolon.
Yeah, this
Separated.
one?
Yeah, I didn't.
Oh.
Well, yeah, because I didn't see the function being separated by the prime function. Yeah, that's my fault.
Okay, no problem. Okay, so let's look at, let's say 50. let's look at part A. So we are asked to find P prime of 2. P of x is f of x times g of x. And we're asked to find P prime of 2. What do I have to do first?
Find P prime.
Of course, if I don't find P prime of x, I cannot find P prime of 2. If I don't have the function, how do I plug in something I don't have? Good. So then P prime of x will be, this is
F prime of x
very good, times,
P or G of x.
very good,
plus
yes.
G or F prime, or no, F of x plus times G of, I can't speak.
That's okay.
I knew what
So
it was.
then P prime of 2 is clearly f prime of 2 times g of 2 plus f of 2 times g prime of 2. Agreed? Good. Now we're not given all this information. We are given graphs. So let's find the g of 2 first. So here it is. G is in blue and f is in red.
It's 2. G prime of 2 is
So g of 2. G of 2 is
2.
2. Do you all agree with g of 2 being 2?
Yes.
Okay. So then this is 2. Now let's determine f of 2, and f is in red.
3.
Do you all agree with f of 2 being 3?
Yes.
Okay, so that is 3. Now let's find f prime of 2. What does that mean? The slope of the tangent line to the graph of f at 2, correct? Okay, so at 2, here it is.
It's like 0.
It is 0. Do you all agree with 0? So f prime of 2 will be 0. So this piece is 0. Now we only have to determine g prime of 2, the slope of the tangent line to the graph of g at 2. So g is here. So what do is I create a right triangle, and I want to use the corners of the grid just to make sure that I'm not making a mistake. And I see there is a rise of 2 and a run of 4. Rise over run for the slope of this line is 1/2. Rise is 2, run is 4. So it's 1/2. So this is 1/2. So the answer is 3/2. Because 0 times 2 is 0, and 3 over 1 times 1 over 2 will be 3 over 2. Any questions? Any questions? Okay. 3.3. We're going to look at trig functions. And their what? Thank you. So in other words, at this point, we want to remember what sine prime is, what cosine prime is, what tangent prime is, cotangent prime, secant prime, and cosecant prime equal to.
You're doing so well.
So pick either sine or cosine so we can prove it. I will not ask you to prove it. I just want to show you at least one of these functions. And you do not have to do anything. You can just watch and relax. Or if you say, I don't want to see the proof, then we don't have to do it. Okay, so which function? Either sine or cosine. Why I'm choosing sine or cosine? Because once we know the derivative of sine and the derivative of cosine, we will be able to determine the other 4 with no effort, using the derivative, the rules of differentiation. We want to do sine. Very good. So let's say sine x. But it will be done using the definition. So f prime. It's a good reminder of what f prime is. What is it? Exactly. Thank you. Very good. From?
Sine x plus h
Very good.
minus sine x
Very good.
over h.
That's it. We will be able to get this derivative, but we will have to use a lot of trig identities. Obviously, I cannot do anything to this, and I cannot do anything to this, so I have to remember what this equals to. So, limit sh approaches 0. Anyone remembers what sine x plus h equals to? Sine of an angle plus another angle. The sine of a sum of angles. Sine x times
Sine H.
cosine h plus,
Sine H.
very good, times,
Sine X.
very good, minus sine x. So we use the first identity, sine of alpha plus beta, or sine of a plus b, as sine a cosine b plus sine b cosine a. That was the first trig identity we used. Very good. My next step is to look at this and look at this, because there is nothing else I can do at this point, just to notice that these two pieces have something in common. What do they have in common? Good. So let's go that route and say limit as h approaches 0. I will factor out sine h, and in parentheses,
So the
Cosine H minus 1.
very good. So far, so good. At this stage, we didn't do anything. We just factored from two terms. We factored out sine x. So we factor from these two terms, we factor out sine x, and we had cosine h minus 1, and I just simply copied the other term. Now is the time to use one more trig identity. But this is a little bit twisted. The identity I have in mind is 1 minus cosine h, which equals, if you remember, 2 sine squared h over 2.
so would it be negative?
Yes, I would have to factor out negative 1. Awesome. So basically, if you can also go back to your previous notes from pre-calc, but this is the formula that is sine squared h over 2 equals 1 minus cosine h over 2. This is where it comes from. So yes, I will have to factor out negative 1 and then write this instead of cosine h minus 1. So I'm ready here. I hope you are too. So this is limit as h approaches 0. Instead of this, I will write negative. So it's negative 2 sine x sine squared h over 2 plus sine h cosine x divided by h. So we replaced cosine h minus 1, factoring out negative 1, so it becomes 1 minus cosine h. And then I replace this. So negative 2 sine x that I had before, and this quantity as sine squared h over 2. Here's the next identity.
How did you get negative 2 in front of sine x?
So I have to write this, because it was cosine h minus 1, not 1 minus cosine h. So first I factor out negative sine x, and then 1 minus cosine h. So now I can replace this by 2 sine squared h over 2, but there is a minus in front.
Where's the 2 come from? Like, I understand. Yeah.
That is the 2.
How's that going from the Sine?
Because I can organize 2 times 3 times 4 is 2 times 4 times 3, 3 times 2 times 4. I can rearrange product. The product is commutative and associative.
That was just kind of like a side note substitution. I don't know if that helps.
Okay, here it is. Is 2 times 3 times 4 the same with 4 times 3 times 2 the same with 2 times 4 times 3?
Yeah.
That's what I did. So I replaced this piece by 2 times sine squared, but I put the 2 in front because it's sine x times 2 times sine squared. I wrote it as 2 times sine x times sine squared because the product is commutative and associative. So I had minus, I had sine, and this was replaced by 2 sine squared h over 2. This is all a product. Is that better? So,
Yeah.
so I had negative, I had sine x, and I had 1 minus cosine h. This becomes negative sine x multiplied by 2 multiplied by sine squared h over 2. I don't like this, so I'm going to write negative 2 sine x sine squared h over 2.
It would have been better if you were my pre-calc teacher.
Oh, sorry. Is this
Nothing against him. He was great.
is this better?
Yes. Oh yeah.
Okay, very good.
I get that.
So that's how we got this. Now I have to work on this piece. We're close. And I have to remind you of one other rule or identity, trig identity, that says that sine h can be rewritten as 2 sine h over 2 cosine h over 2. That's another trig identity. And it comes from this, from sine twice x equals 2 sine x cosine x. It's a double angle identity. But now h is 2x, so then this must be h over 2 and this must be h over 2. So finally I'm going to replace this piece by this. And then you'll see what happens. And it will be straightforward from there.
Are the two signs going to cancel each other?
You'll see in a moment what happens. You're way ahead of me, which I love. So limit as h approaches 0. Negative 2. I copy sine x. I copy sine squared h over 2. And I copy plus 2. I copy sine h over 2. Cosine h over 2. And I cannot forget the cosine x. Divided by h. And now you know what I'm going to do next. So I have a term here with negative 2 sine x sine squared h over 2. And I have a term here with 2 sine h over 2 cosine h over 2 cosine x. And I know you know what I'm going to do next.
Are you going to make some more out?
What do you think?
Yes.
So I have a negative 2. Or at least 2. We'll see in a moment. In common. Then I have a sine h over 2 in common. And what is left in brackets? So 2 is out. One of these 2 is out. So obviously I have a negative. I have a sine x. And I have a sine h over 2. Agreed?
Agreed.
Good. Then I have a 2 which is out, and I have a sine h over 2 which is out, so I have these 2 left over. So this is cosine h over 2 cosine x. Okay? Now, do you allow me to write, instead of 2 sine h over 2, you tell me if this is fine with you. When I flip this, I have 2 over h. So if I have a 2 in front, or if I have it in the denominator, it doesn't make any difference because I still have to flip this and I get 2 over h. And now let's think what we have to replace this by. And I'm going to read it to you in the correct order. Cosine alpha, cosine beta minus sine alpha, sine beta. Cosine alpha, cosine beta minus sine alpha, sine beta. Let me write it. Cosine alpha, cosine beta minus sine alpha, sine beta. What does this equal to? Cosine. This is still trig. This is another trig identity. Cosine of a sum of angles is cosine alpha, cosine beta minus sine alpha, sine beta. So what would you tell me to change this into based on this trig identity? Obviously, you're going to say cosine. Very good. It's done. Okay. As h approaches 0, I would like you to tell me where this is going. Exactly. And this is the limit that we studied a month ago. And when h approaches 0, what is the answer? That's it. So what is the derivative of sine prime? What is the derivative of sine?
Yeah, now I wish I didn't ask for this. Should just give me the answer. I don't like that.
You don't have to do anything with it. So now, if we do the same steps, cosine prime will be the opposite of sine x. Yes?
Do we just have to remember all of that, or just the part of that?
You will only have to remember that sine prime equals cosine. You do not have to remember the proof
At any point during this class.
at any point during this class.
Maybe for extra credit?
Yeah.
Okay, very good.
Why would you do that?
Good. So then, let's take a look at tangent. Differentiation rules. No, not the definition of the derivative. So this is the same with? Very good. So in order to determine the derivative of sine over cosine, what do I need to use? Very good. Awesome. So the quotient rule would say sine prime times cosine minus sine times cosine prime divided by cosine squared. How much is sine prime? Times cosine x will be cosine squared. How much is cosine prime?
Negative sine.
Negative sine times negative sine will be?
2 negative sine.
No.
Sine squared.
Sine squared, very good. Divided by cosine squared. But how much is sine squared plus cosine squared always? 1. Divided by cosine squared. And what is 1 over cosine? What function is that? Secant. So this is secant squared. So then we will know from now on that tangent prime equals.
Secant squared.
And we can continue with the other three. So let me give them to you. Tangent prime is negative cosecant squared. Secant prime is secant times tangent. And cosecant prime is negative cosecant cotangent. Let's practice this a little bit. On page 197, please choose anything you want from 1 through 16. 1 through 16 on 197. Which one? 12. Let's take a look at 12. Y equals cosine x over 1 minus sine x. Very good pick. By the way, can I change this into a product?
No.
Of course not. Why? Because the denominator has
There's more than one.
2 terms. Correct. Very good. Very good. So,
Cosine or prime. So
ready? So y prime. Top function prime. Negative sine x multiplied by 1 minus sine x minus
cosine.
cosine x multiplied by the denominator prime, 1 prime 0, minus sine prime is cosine, so it's negative. So plus cosine squared divided by 1 minus sine x, everything squared.
Says cosine squared x.
Yes,
Well, yeah, but it would have been negative, but it was already minus.
yes.
She's turning to a plus.
Now, one thing will make me cry if somebody would simplify this with this. Is that clear why we cannot do it?
Yes.
Very good, because this is a part of a term and this is a factor. So I will try to simplify a little bit if possible. So I distribute negative sine x plus sine squared plus cosine squared over 1 minus sine x squared. And there is something I can do here. What is it? Looking at sine squared plus cosine squared, that is 1. So I'm going to write 1 minus sine x, and you'll see why I'm writing 1 minus sine x. Because I noticed that. Right. So the simplified form is 1 over 1 minus sine x. Any questions? Any questions?
Can you just repeat that? last?
Yes. Yes, let's do that from the beginning. Top function cosine prime is negative sine. Then I copy the bottom function. And then minus. I copy the top, but I have to differentiate the denominator, which will be cosine, but with minus in front. So I had a minus cosine times a minus cosine gave us plus cosine squared. Is that better? So I would have had negative cosine x multiplied by the denominator, which is negative 1, times sine prime, which is cosine x. So because I have negative and cosine, I have positive cosine squared. Now I distribute negative sine x to 1 and negative sine x to negative sine x. And I copy cosine squared. Now this piece equals 1. Sine squared plus cosine squared equals 1. And I rearranged it as 1 minus sine x, just because I wanted everyone to notice that 1 minus sine x with 1 minus sine x from the bottom go away. So that's why the numerator is 1 and the denominator just 1 minus sine x. Is that better?
Yes.
Very good. Questions? Questions? Okay, would you like to choose another problem, anyone? Or we continue with some other type of problems?
$16.
16? Very good. Let's take a look. And after this one, we are going to Ben read form choosing. And you'll see why. Same page, 197. Here's why. I'm kidding, of course. Here's a slightly more sophisticated problem. Can anyone tell us why this is a little bit more sophisticated? Exactly. Because of 3 functions. So this is function 1, this is function 2, and this is function 3. So there is a rule for this. But I don't really want to go and ask you to memorize another rule. So what we're going to do is, I'm going to consider that this is function 1, and I'm going to consider that this is function 2. And you can say, why did you group them like that? It doesn't matter. We can choose x squared to be function 1 and sine x times tangent x function 2. It doesn't matter. I didn't even look. So y prime will be x squared sine x prime, let's write it like this for everyone to see, times tangent x plus x squared sine x times tangent x prime. Is this clear? However, what do we have to use on the very first part? The product rule. Because these are two functions. This is a product of two functions. So in order to determine this derivative, I have to use inside the product rule. The rest is clear. There is no problem here. But I have to determine the product, or apply the product rule for this. The first function prime, 2x, times sine x plus x squared multiplied by the second function prime, which is cosine x, and everything multiplied by tangent x, plus x squared sine x, and now tangent x we know is secant squared. So everything is done when it comes to the differentiation part, but I will have to distribute tangent, and then I can't do anything anymore. So let's distribute and remove parentheses. 2x sine x times tangent x plus x squared cosine x tangent x plus x squared sine x times secant squared x. So here's the rule, the shortcut, but again, I'm not going to ask you to do this. So if I have 1 times 2 times 3 functions prime, is 1 prime times 2 times 3 plus, what do you think?
1 prime, 1 plus 2 prime, right, times 2.
Exactly. There is no need for this. To memorize it, that's what I meant. Any questions?
And then if it was 4, it'd just be again, but it's a 4, right?
I have not. I shouldn't say yes. I will have to look at the result and make sure that there are no other terms in there. There may be more than just. I wouldn't say yes just yet. I'll have to look. Yes. Okay. Now I would like to show you something that is not going to pop up in this chapter, but I don't want to wait till the next chapter, because now we have all the information we need in order to be able to apply this very, very important rule. There was a mathematician whose name is L'Hopital, his last name, and who created a rule, which is a very smart rule, very intelligent result. He said this: if you're trying to find the limit as x approaches a from a ratio, and you plug it in and you get only one of these two indeterminate cases. So if you're trying to find the limit of a ratio, nothing else, it must be a ratio, and you encounter one of these two indeterminate cases, 0 over 0 or infinity over infinity, you can determine the limit by simply not applying the quotient rule, but by simply differentiating the top by itself as if it's alone on the planet, and the denominator by itself as if it is alone on the planet. So do not confuse or not apply the quotient rule in such a situation. When we determine the limit and we have 0 over 0 or infinity over infinity, only in those cases, then we will go ahead and say this is the limit of the top prime over the limit of the bottom prime. Never to be confused and later on and say, oh, no, I'm differentiating a ratio. Top prime, bottom prime. No. Okay. So now I would like to look at few limits. Like, for example, limit as x approaches 0 from sine x over x. Have we seen this before?
Given the limit.
What is the answer? Okay, let's say we don't know that. Because remember, the first day of classes pretty much, when we looked at this limit, I said, I don't have the tools to show you what it is. And what did we do? With the function, what did we do to find the limit? We graphed it, right? We graphed the function, and we saw the graph, and we saw that right there where it's x equals 0, it's an open point, but since both sides approached, the limit was good. So now we are ready to prove this using L'Hopital's rule. But only if I encounter these two, one or the other. So the top goes to, the bottom goes to, very good. So then limit as x approaches 0, I'm applying L'Hopital's rule because it's 0 over 0 and it's a ratio. The top prime, the bottom prime. So now what is the limit of cosine x when x approaches 0 from either side? 1. Here's another limit. On page 198, please choose. 39 through 48.
40.
Which one?
40.
40. So we have limit as x approaches 0 from sine 4x over sine 6x. I do run into a little problem here because the next section is the chain rule, and we don't know the chain rule, and we cannot apply it. So it is 0 over 0. We will apply L'Hopital's rule, but after we finish the next section, because this is not plain sine x. We don't know how to differentiate sine of a function of x yet. We only know how to differentiate sine x, but it's 4x. This is a totally different function than x. And it's 6x, which is a totally different function than plain x. But what we can do still, we have limit as x approaches 0. Now, I hope you agree that when I say x approaches 0, I also mean 4x approaches 0. I also mean 6x approaches 0. Agreed? Good. So then I'm going to do this. Okay. So what should I have here at the bottom so that I can use the limit from before, which is this limit, where this box, and this box. Yes. But if I multiply the denominator by 4x, I have to multiply the numerator by 4x. And this is 1. And I'm safe. What do I need at the top of sine 6x? But if I multiply the numerator by 6x, I have to multiply the denominator by 6x because this is 1. So now all I would like you to tell me is, where does this go? And where does this go as x approaches 0, or actually 4x approaches 0, or actually 6x approaches 0? Where does this go? 1. Where does this go? And I have 4x over 6x. Where does that go? Well, of course, I'll simplify the x, right? I remove an x from the top and an x from the bottom, and then I get 2 over 3. We can revisit this after we look at the chain rule, in which we will learn how to differentiate a function composition, a function that is inside a function, which we don't know yet. We only know how to differentiate simple functions. We don't know how to differentiate sine of another function yet. It's function composition. I know I have 5 more minutes. Let's do one more and then we'll stop. Please choose another one from 39 through 48. If we can use L'Hopital's rule, we will. And let me choose one in which we can use L'Hopital's rule. Yes, for example, 42. In 42, we have limit as x approaches 0. I'm sorry, it's theta. Theta approaches 0 from cosine theta minus 1 over sine theta. So now, moving forward, you should always feel free to apply L'Hopital's rule if you have 0 over 0 or infinity over infinity. There is no restriction moving forward. If you can apply it, apply it. If you cannot apply it, then there are other ways. First, I have to check. When theta approaches 0, cosine, 0 from either side, cosine approaches 1. 1 minus 1 is?
0.
Good. And then when theta approaches 0, sine 0. Can I apply L'Hopital's rule?
Yes.
Is it a ratio?
Yes.
Is it 0 over 0? Yes. So then I will write limit as theta approaches 0. What is the derivative of the top by itself?
Negative sine theta.
What is the derivative of the bottom by itself? I try again. Where does the numerator go?
0.
Where does the denominator go? 1. Is this an indeterminate case or undefined case? It's a not undefined because it's 1 in the denominator. It's not indeterminate.
0.
The answer is 0. It's a very useful theorem in those cases. Any questions? I have 3 more minutes. One more. Promise, I promise. Many of them are on the checklist, I'm sure. I did not look, so if you're careful and you redo the notes, you will have no difficulties. Why I would like to do this? Because we did this together before. But we factored it, and we used the limit that we knew. But now I want to use L'Hopital's rule. Okay, where does the top go?
0.
Yes. Where does the bottom go? Good. Okay, so let's try. Limit as x approaches 1. It's a ratio, and it's 0 over 0. The derivative, I can't. We don't know sine of a function, prime. So I have to go back to sine x minus 1. We don't know that yet, and factor the denominator. We had this on the previous test that I just returned. Similar question. So the denominator will be obviously an x minus 1 because that creates the problem, and an x plus 2. And this is when some of my students simplify the x minus 1 from inside the sign and with x minus 1 from outside. So now we know that since x minus 1 approaches 0, I have one box, a second box, and a third box. Where does this go? 1. And the whole thing goes to 1 over? Well, but I'm applying the limit. I dropped the limit operator.
2.
Try again.
3.
Oh,
3.
yeah.
Very good. So we couldn't do that yet.